All right, so in this video, we're going to be talking about irrational approximations. So given our classifications and what we've been working with, remember the pyramid represented rational numbers, anything that can be written as a fraction. Here we have our irrational island. So we need to keep in mind a couple of definitions that we learned about irrational numbers. Irrational are numbers that can't be written as a fraction. So you're like, wait, what's that even mean? That means the numbers that come out that are irrational will never, ever, ever repeat, and they will never, ever, ever terminate. Okay, so we had worked with decimals and converting them to fractions and back and forth. Well, in this instance, we have our never cases, which is why they're on an island floating by themselves. And we've learned that there's only two cases of irrational numbers. Anything that has pi, and any number that is not a perfect square. So these two types of numbers never repeat, never terminate, which means they're irrational. Again, pi and not perfect squares. Okay? So what we're going to be kind of taking a look at today is how to give them values. So in order for our brains to process these numbers, we have to approximate or we have to estimate what their values actually means. Okay, so first thing that we need to remember is what are perfect squares. So right here I have a simple number line 1 through 7. Okay, so our brains can process 1, 2, 3, 4, 5, 6, and 7. And in processing 1 through 7, we have our square roots, our radicals that correspond with them. So the number 2 is the square root of 4. The number 4 is the square root of 16. The number 7 is the square root of 49. Okay, so what this also means is that there is values in between here. So for instance, I have the square root of 2 and the square root of 3. 1, 2, 3, 4. Which means the square root of 2 and the square root of 3 have to be some sort of decimal that's 1 point something because it falls between 1 and 2. The square root of 5, the square root of 6, square root of 7, and square root of 8 all have to be 2 point something because they fall between 2 and 3. And we can continue doing this with our number line completely through if we wanted to. All right, so what I'm going to be doing today is I'm going to be showing you two ways that we can approximate these irrational numbers. One of them is going to be by hand to the nearest whole number, and the other will be using our calculator. All right, so the first one that we're going to be working with is the square root of 23. All right, so we have the square root of 23, and the question is, what is its approximate value? All right, and I'm going to do this again without a calculator. So my first step is I'm going to find what two perfect squares is the square root of 23 in between. So remember, our perfect squares are the top part of our number line. Square root of 1, square root of 4, square root of 9, square root of 16, 25, and so forth. So we would say, okay, well, the 23 is, so we track our number line. And the square root of 23 would have to be between the square root of 16 and the square root of 25 because it falls somewhere here on our number line. So we're going to write square root of 16 and the square root of 25. Okay. We then need to figure out, well, who am I closer to? Am I closer to being 16 or am I closer to being 25? And in this case, I'm 2 digits away from being 25. And I am 7 digits away from being 16. So in this case, I am closer to being 25. Therefore, I am approximately the value of 5. Now, if I look at this number line and where he falls on here, notice I am not 5.0. I'm 4 point something. And it's probably a higher value, close to 5. So I'm closer to being 5, but I'm probably like 4.8. All right. So let's do another one together. All right. Actually, yep, we can do this one together. We have the square root of 88. Now notice my number line ended at 49. So we kind of got to continue our number line here. So from here, we would have the square root of 64. So that's 8 times 8. We have the square root of 81, because that's 9 times 9. We have the square root of 100, which is 10 times 10. So where would 88 fall? Well, 88 would fall between the square root of 81 and the square root of 100. Now the question is, who am I closer to? Well, I am 7 digits away from being 81, and I am 12 digits away from being 100. Now notice these numbers are kind of close, which means I'm almost at a 0.5. I'm a halfway, but I am actually closer to 81. And the square root of 81 is 9, which means I am closer to being the whole number, so approximately the value of 9. Okay? Sometimes, though, the rational approximations that we're dealing with are big numbers, and my number line doesn't go that high. So let's take a look using the calculator what I can do for these approximations. So first off, remember the square root is the opposite of squared. So we're going to type in second square root, and we're going to type in 342. All right, so my calculator displays all of this information. So I'm going to go ahead and put equals, and I'm going to put 18.493 ... because there are more digits. And then it's going to be whatever they're going to ask me to. If they ask me for the nearest whole number, that means the numbers that are in front of the decimal. I'm not quite halfway, so the nearest whole number would be the number 18. If they ask me for to the tens place, I would say that this is 18.5, because that 9 tells the 4 to bump up. And if they said to the nearest hundredths place, I would say that this is 18.49. So all depending on how they ask me for my data, I can use the information in my calculator to then plug it in. All right, so this last one together, we have the square root of 265. Okay, all of the digits say that I am 16.2788 ... So to the nearest whole number, I am approximately 16. To the nearest tenths of a value, I am here. The 7 tells me to bump up, so I am 16.3. And if I said hundredths place, the 8 tells the 7 to bump up, so I am 16.28. Okay. So hopefully this video helps you out with finding out our irrational approximations.